Welcome to ASGCT. My name is Anne. I'm the automation manager here at Curios, and today we're going to go over an example of how to put in a protocol onto the AUTO1000 using the Hamilton software that we have developed and built with Hamilton. So once you are in run control, which is the screen we are currently seeing, go ahead and select the correct method to run and hit play. So you can see that the system is setting up, it's calculating all its positions, and then we get into the launch screen. So the beginning of the day, what we would do is execute the daily startup maintenance, and we can also check dispensing and aspirating performance after the startup. Once the startup maintenance is done, let's go ahead and set up a protocol. So hit run a protocol and hit continue. We'll be taken to the first screen. So we have two options here. Either we can configure a new run for one plate or two plates, or we can even load saved run parameters from previous runs that we've saved. Today, let's go ahead and do a new run for one plate. Continue. Okay, this is how we are going to build a protocol on the AUTO1000 through the user interface. So you can see on the top left, we're building assay for plate 1, and we're in loop 1. Every loop consists of a transfer of some sort, so either a sample, an antibody, or a buffer transfer, followed by an incubation of some sort and a wash of some sort. So you can skip incubations and washes just by entering 0 in these boxes, or you can select the time that you wanted to incubate and how many wash cycles to do. So the first step is always to do a sample transfer. We will be transferring from the sample input plate onto a laminar wash plate. Let's go ahead and transfer 50 microliters from the sample input plate onto the laminar wash plate. We can have it vortex after the transfer, and this will spread the cells out throughout the wells. Today, we are going to do 4 samples, and we will also do 4 replicates. So we will have a total of 16 wells on the laminar wash plate. I will also have it pipette mix the source plate in case the cells have settled while we're setting up the rest of the experiment. Now, I typically like to incubate this at 30 minutes at 4 degrees or at room temperature, and then we will wash it 9 times at 10 microliters per second with port 4. So typically, a user will have access to 2 ports or up to 6 different wash buffer ports. The system I have only has access to 2 ports, so we will select the first one, and this will wash with something like fax buffer or PBS or whatever it is I've connected to it. And then we want a vortex plate after wash. So what this loop is doing is that first we will transfer a sample from the sample input plate onto the laminar wash plate. We will give it some time for the cells to settle, and then we will wash it. And this essentially washes out the old media, which could be RPMI or some sort of media that it was in, and replace it with a new buffer, such as PBS or fax buffer, so that we can do the staining steps. This step can also be skipped if you would like to. So I'm going to hit continue, and then we get to a confirmation page. So we want to confirm that all entries are correct, because once we confirm the first loop, we cannot go back to it to change any more functions. So I've taken a look, all this looks really good, and I will then hit confirm. And this gives us a choice to enter another assay step. Let's go ahead and do that. So now we are on the top right-hand corner. You can see we're on loop 2. So we've done the sample transfer. We are now going to do an antibody panel transfer. Let's go ahead and do 50 microliters per well. We will pipette mix after the transfer. And let's do 2 panels for this step, for example. So let's say I want to have the first panel only go to 1 sample and panel 2 go to the remaining 3 samples. So again, up here on the top right, you can see that we have 4 samples at 4 replicates. All the replicates will be treated the same. Let's go ahead and incubate for 30 minutes at 4 degrees Celsius. We'll do 9 cycles washing at 10 microliters per second with the same fax buffer, for example, that's in port 4 and vortex plate after washing as well. That's it. That's the first staining step done. Once this is all done, I'll hit continue. We get to the confirmation step again. I've looked through all of these, a panel transfer, the volume is correct. I will do 2 panels in this step. The first panel will go to only 1 sample, and the next panel will go to all 3 samples. We'll incubate 30 minutes at 4 degrees Celsius. We'll wash 9 times at 10 microliters per second with this buffer that I have in port 4, and then vortex plate after washing. This looks good, so I'm going to hit confirm. And let's go ahead and enter another step. So for this step, for example, if I want to do intracellular staining next, I do want to fix and perm my cells. And for that, I will go on to buffer transfer, and I'm going to add 50 microliters of the buffer. In this case, it could be a fixed perm solution. And we'll pipette mix after the transfer. And you can see that when I've selected buffer transfer, the bottom right hand side, all these options are grayed out because the buffer will go to the entire plate to all samples. Whereas an antibody panel gives you the choice to select how many samples get receive how many panels. So I've done the buffer transfer for everything. And let's say we incubate for 45 minutes here because we want time for the cells to settle as they're being fixed and firmed at 4 degrees Celsius. And then we will wash 9 times at 10 microliters per second. And now we're washing with perm wash, which is no longer fax buffer. So let's go ahead and select a different input port. I will be connecting perm wash to this port. And we can vortex plate after washing again to unsettle the cells. And that's loop 3. Confirm that this is correct. Again, I'm doing a fixed perm at 50 microliters per well, and I'll pipette mix after transfer to the laminar wash plate. I'll incubate the cells for 45 minutes with a fixed perm solution at 4 degrees Celsius, and then I'll wash 9 times at 10 microliters per second with the perm wash, which is what I will be connecting to port 5, and then we'll vortex plate after washing. Confirm this step. Let's go ahead and enter our intracellular staining step now. That will be an antibody panel transfer. So let's do 50 microliters again. That's pretty typical for most of our protocols. And let's do, for example, 2 panels in the step. And maybe I want each panel to go to 2 samples. So samples 1 and 2 will get panel 3. Samples 3 and 4 will get panel 4. Let's go ahead and incubate for 45 minutes here at 4 degrees Celsius. Let's do 9-time wash at 10 microliters per second. And again, we're washing with perm wash. So that's in port 5. Vortex plate after washing and hit continue. Let's confirm this step. Again, this is the intracellular staining step. So we're going to transfer 50 microliters of the intracellular stains. And we'll do 2 different panels in this step. Each panel will go to 2 samples. We'll incubate 45 minutes at 4 degrees Celsius or whatever is equivalent to the fridge. Wash 9 times at 10 microliters per second with port 5, which is perm wash, and vortex plate after washing. And this looks good. Let's go ahead and click confirm. And at this point, I'm actually done with the assay. And I just want to take the plate out. So I'm going to select no more assay steps. It will ask if you want to transfer the process sample out to an output plate, which is another V-bottom plate. So this is what we would recommend if you are leaving the plate in the fridge for maybe a week or so before you acquire a cytometer. Go ahead and transfer. The laminar wash plates are also compatible with most cytometers. So if you want to go ahead and acquire it directly from the laminar wash plates on the flow cytometer, you can leave this unchecked. Today, I'm going to have it do a transfer, continue. Now we have a plate layout. So at the top, you see there are 4 samples and there are 4 replicates. So they're plated in this fashion. Unique samples are plated vertically. So samples 1, 2, 3, 4. And replicates are plated horizontally. So sample 1, all the replicates go horizontally. So we have this 4x4 square here. You can also see the panel treatments at the bottom. Panel 1 is only going to sample 1. Panel 2 goes to sample 2 to 4. These are our surface staining steps, quote unquote. And then we did a fixed perm step, and panels 3 and 4 are what would be our intracellular panels. So panel 3 goes to samples 1 and 2, panel 4 goes to samples 3 and 4. This is just an example protocol just to show you what the GUI is capable of doing. When this is done, let's go ahead and hit continue. And then we can save these parameters. We can hit continue so that we can come back and use the protocol again if we want to in the future. This is an instrument deck instruction. So whatever is flashing here, you can see this spot here is flashing. This is where we will load our 1 sample input plate. So once you've loaded that on the auto deck, go ahead and check this. And you can see the next spot is flashing. This is where we will load a fresh laminar wash plate. When that is done, we'll load a reagent plate right here where it's flashing, and the reagent plate is a deep well plate. And then we have 300 microliters stacked tips, which is what we are using on the system that we have. Okay, let's go here. And then it will also calculate if we require big volume plates or large volume adapters for this protocol. And right now we don't need any for this protocol, so don't load any. And we do need 1 output plate. So go ahead and load that here. When this is all done, we can hit continue, or we can go ahead and skip all. So I'm in simulation mode as I'm running this. And so you can see this is the trace file that is going. And this is a trace log that is generated that records everything that happens during a run. This will be saved at the very end of the protocol as a notepad file. And so you always have a trace of what has happened during a protocol. If something goes wrong or if you forget what you've had the machine do, there's always a record of that. There will also be a mapping file generated at the end of every protocol, at the end of every run, so that you know how much volume was pipetted from what well to what well. So that is a very good thing to have just for your own records at all times. Are there any questions?